Clean up on aisle, GitHub Copilot. I mean, I love Copilot as much as anybody else does, believe me, and I use a lot of it. But sometimes it does come up with some odd code. So in this video, we're going to take a look at some code that GitHub Copilot created and see if we can do better. Let's go over in VS Code and check it out. All right, so what we have here is some directions, I guess, that were given to GitHub Copilot. And it's basically an interview question. So the idea is you make a function called maxChar. It takes a string. In this case, it's an ABC with a lot of C's, D. And the idea is give us the character that appeared the most in this string, which is in this case is C. And in this case is 1. So I can see why this is a good interview question. It's got some looping, it's got some lookups, it's got some math. So it's pretty cool. All right, let's go take a look at what Copilot did as its initial implementation. So I'm going to go and take that and copy it out of the README. And I'm going to bring up a Quokka sheet. I'll paste that in there. So what is a Quokka sheet? Well, Quokka is a VS Code extension that gives you workbook style functionality. So it's constantly running this TypeScript code. But as you can see right now, it's got these white boxes over here. And that means that this maxChar code isn't running because we're not actually running it. So what do we need to do? Well, we'll bring in a simple little test setup. So I'll copy and paste this in here. And I'll put this at the end. And well, what is this? Well, I've created a simple expect function. It takes a Boolean value, and if that Boolean value is false, then it throws an error. So in this case, we're going to call that expect, but we're going to call it with maxChar, and then we're going to take those examples that were in that documentation up front, and we're going to go and see if those evaluate to true. So maxChar of this should equal C, and if that's true, then expect will pass. Let's go make it fail. I can go and change that to D, for example, and it'll fail. It'll throw that expectation. We can see now that we are getting reds. So we've got a nice little testing mechanism there that we can see live, which is great because I would never try to refactor any code without first having a comprehensive set of tests for every single edge case to make sure that my changes weren't breaking anything. So let's go take a look now at the existing code and see what it does. So the first thing it does is create a variable called cache, which acts as a lookup between the character and the count. So in this case, like a character would be A and the count would be 1, B would be 2, I think, and so on and so forth. So that's going to give you that lookup. That's what the cache is called. I think it's a bad name. Then we're going to split that string into its component characters using string.split and an empty string. And then we're going to iterate through each one of those characters one by one. And we'll look at that lookup or that cache, and we'll say if you've got a cache element in there, then just add 1 to it. And if you don't, then create a new cache element with that character and set it to 1. And now once that's done, so then we're going to iterate through all the keys in that cache, and that's going to give us A, B, C, and 1. So it's a smaller subset, okay. And then we're going to dereference that key, so A, B, C, D, and so forth. And we're going to compare that count that comes in here with the maximum count. And we're going to create that maximum count by looking at all of the values in the cache. So that's going to take that lookup table and just take all the values from it and turn it into an array. So if I go over here and I select that, you can see over here that array is like 1, 1, 1, 7, so on and so forth. And then we do a math max on that, and that gives you the maximum value. All right, so now that we know what this function does, we'll talk about how to improve it. And the first thing that I see is a TypeScript issue, and that's that we're using as here to define what this cache is. And that's just kind of syntactically bad when it comes to TypeScript, so I'm going to remove that, and I'm going to declare it what I think is the right way or preferred way in TypeScript, which is to put it colon and then give it the type. Now I like that record, that's actually good, so that's cool, I'll keep that. So this is exactly the same thing. Test pass is fine. So there's a misunderstanding when it comes to let versus const when it comes to arrays and objects. When you define an object as a const or a let, you're actually not defining the contents of the object as constant. You're defining the reference to the object as constant. So you can still change the contents. You just can't change the reference. And so you could actually get by doing const right here, and that's not a problem. You can actually change the contents of cache, and it works just fine. Now, maybe you don't like that, maybe you think it's a bad thing, but that's just the way that JavaScript and TypeScript work. All right, the next thing we can do is down here, we've got kind of an efficiency problem. So we got an ON loop here, And then within this, we've got another ON loop to get the math max of those object values. And I could actually argue that object values is in itself an ON function. So we've got, at the very least, an efficiency of this loop of ON squared, which is not great. I mean, this is not terrible in this case. I mean, we're just talking about, small amounts of numbers, but whatever, it's not great. So it's actually an easy fix. All we need to do is just grab this math max because it doesn't change and just take it outside. We're going to call this max. And I'm going to set max up here to be that math max with those object values. The other thing we can do is actually pull out this number. This is actually over-specified in TypeScript. TypeScript knows that cache is a lookup between a string and a number, and that the key is a string, and that the values are numbers. So saying object values of cache is going to give you an array of numbers implicitly. Okay, so this, it's improved. So we'll call this basic cleanup. So I'm going to copy this out. And in our README over here, I'm going to keep a tally, essentially, a running list of our alternative implementations. And we're going to call this one the basic cleanup. I'll just drop it in there. And of course, all this goes into GitHub, and all that code is available to you, and you can play with it yourself. It's really fun, actually. I find these kind of things really fun. The sort of things that you can do maybe as you're watching TV or whatever, or you could just kind of work on your skills by honing code. I think it's actually a really good way to keep your skills honed. Let's go back here and see if we can do a little bit better. I think definitely there's a lot of room for improvement. So one thing is that we're not actually doing anything with this array beyond just having it be the output of string split. We're just giving it to this for loop here. So I can just cut this out, paste it into there, and just save ourselves a line. So that's pretty easy. So the next thing my eye is drawn to is this if-else construction over here. And what is that doing? Well, it's saying, okay, if I've got a value, then add to it. If I don't have a value, then create a value. The way that I like to do is I like to say, if I don't have a value, then set that value to 0, and then unconditionally set the value to +1. So how would we do that? Well, we'd say if there's no cache, then set that value to 0 to initialize it. And otherwise, we just unconditionally set that cache ++. So that cleans that up a little bit, but you can actually get even more terse with this. So I can just say, okay, so we'll start off with cache C like that. And I'll take the GitHub Copilot suggestion. We'll actually help GitHub Copilot improve its own code. And here we go. We'll get rid of the old code and walk through this. So what is this? Well, we're basically saying cache C equals, and then we'll start with either cache C or 0. So in the case where cache C is undefined, we'll choose 0 for that. And then we'll add on 1 to whatever this expression evaluated to. Now you can be a little bit more concise here. I can say question mark as opposed to pipe. Question mark basically says if the value on this side of the expression is either null or undefined, then pick this. Whereas the pipe version basically says if it's any kind of falsy value, then pick this value. So this is just more precise. All right, let's go down, make sure that this is still working. Make a change. That's great. Awesome. Cool. All right, so now I actually think that we have pretty much the best factoring of, all right, so, okay, so now in my opinion, we have a pretty decent JavaScript or TypeScript classic implementation of this function. We're not really using any array functions yet, so we're not moving into what we would have in the ES6 world. So I'm going to copy this out and call this kind of the JavaScript classic version. All right, well, the next thing we're going to do is an ES6 style refactoring of this function. But of course, before we get there, if you're enjoying this video, be sure to leave a comment down below, hit that like button or hit that subscribe button to be subscribed to this channel and get updates the next time a new one of these videos comes out. All right, let's go take a look over at maxChar and continue our exploration and take a look at ES6. So the first thing I'm looking at is this part up here. And when I see these, I'm basically looking at a pattern. And that pattern is that we're creating an object, and then we're iterating through something and adding into that object. And that's what we want the output to be, is that object. So really, The best ES6 match for that is reduce. So we take this array, this string split, and we're going to reduce it and create out of it the cache. So let's go and comment this section out. And I'll do string split here and then reduce. And what do we want this reducer to create? Well, we want to create a record, which is that string to number. So I'll put that in there as the generic. And then what does reduce take as arguments? Well, the first argument is a function. And the second argument is an initial value. So this guy right up here is going to now be down here. So that's our initial object, and that's going to get passed in as the, well, it's called the accumulator. And then every time it goes through one of the items in the split, which would be A, B, whatever, yada, yada, right? That's going to come in as, well, we can name it anything we want, but we name it as C for character. And then what we want as the output of this function is a new object. So instead of doing this style syntax, we're going to wrap this in parentheses, and that's going to say this curly braces is now an object. And what we want in there is we want the current accumulator. So we want everything we already have. And then we want a new value for the given character. And I'll just use that GitHub Copilot suggestion that it did, which is essentially this right here. So what this is saying is basically take the key, which is C, and that's why it's in brackets like that. If I just made it C, then it would always just be the value C. So take the value of C and make it the key, and then take whatever is in the accumulator, or 0 if nothing is in the accumulator, and add 1 to it. All right, now the last thing we need to do is set our cache to the output of that. And there we go. And it looks like we're doing good. So yay, the top section is now refactored into something that I think it looks a little bit more terse. It might not read as well, but if you're familiar with the ES6 reduce, map, filter functions, and you're comfortable with it, this is actually a pretty decent implementation of that. So, okay. So now can we go and optimize this bottom section down here, again, using array methods? And yes, we definitely can. So what we want to do is search through all those keys in cache and then find the value where that key equals the max count. So first off, we're going to return, and in fact, again, we'll use the GitHub Copilot suggestion here. So we're going to say we want the object.keys, which is going to give us A, B, C, so on and so forth. And then we're going to use the find method on that array of keys. And that find method takes a predicate. And that predicate takes the current value, which in this case would be C, or the character. And then it's going to say, okay, for that key in that cache, does it equal the max value? And so it's going to return true or false. And the contract here with find is if you return true out of your predicate, then you found it. And so that's going to return then the key, A, B, C, whatever. Or in the case where it returns undefined, then we're going to again use that question mark to return an empty string. All right, let's take a look. And there we go. Great. Awesome. Okay. So I would call this my kind of ES6 basic implementation. And now from an interview perspective, I mean, I think we've pretty much since the basic cleanup, we've been good. So as an interviewer, I'd be fine with pretty much everything so far. But let's see, of course, if we can do even better, right? So what do we have here? We have 3 different ON loops. We've got this one, which I think is unavoidable. We have to go through every character in the string. We've got this one, where we are getting the math max of the object values, which again, I would say is its own ON. And then we're iterating through the keys. So we're doing an ON there to go and try and find the key that was the maximum value. So the question becomes, can we do this all in one single pass? And we kind of have a starter here, right? We're iterating through every character. And what if we tracked the maximum item and maximum count as we went? So that by the end, we not only had the lookup, but we also had the maximum item and the maximum count. Well, and we can actually do that. So let's give it a try. So I'm going to go down here and I'm going to comment out our bottom section down here. And I'm going to just kind of get rid of that const for the moment. And now we're going to refactor what the output of this reduce is, because it's not just going to be the lookup, that lookup between strings and numbers. It's going to be the lookup, the max item, and the max count. So let's go and say that this is going to be an object now. And we're going to have a lookup, and that's going to be that record that goes from the character to the number. And then we're going to have the max item, which is going to be a string, and we're going to have the max count, which is going to be a number. So now let's jump down here, and we're obviously not setting this up properly, right? It's missing all of these. So let's go and initialize this. I'm going to say lookup is an empty object, and I'll even give it the right type by using the type generic on there. And then max item is going to be an empty string, and max count is going to be 0. So now TypeScript is happy at the moment, but it's not really, because this section in here is actually going to return kind of a different object after the first pass. So we don't want to do that. So the first thing we need to do is change this into a function and then do a return here. And we're going to return an object because we get an object. We get an object that looks like this, and we want to return an object that looks like this. So the first thing we need to do is refactor this object here. So I'm going to recreate lookup. And I'm going to give it all of lookup. And then that count is going to be dereferenced off lookup. But now we're missing max item and max count, right? So how are we going to figure that out? Well, we need to know that for the given value, A, B, C, D, whatever, if the new count for that character is going to exceed the current maximum count. So first thing we need to do is get that count. So I'm going to cut that out of there and then create count. And then go up here and define count to be that. And then I need a Boolean that says, did I become the new max? Am I the new king of the hill? So I'm going to say is max. And it's going to be, is that new count greater than our current max count? Right? And that's going to be true if, like, for example, A is now the new max count, or B is the new max count, or C is the new max count. So, okay, cool. So now let's jump down here and we'll say, okay, so we need to return max item and max count. So max item is going to look at that is max, and it's going to say, if it is the new maximum, then return the current C or character. Otherwise, it's not the new king of the hill, so return the old king of the hill. So, and then the same thing for max count. So if this is the new maximum count, then return our count because we're now the new king of the hill. Otherwise, return the old king of the hill. All right, cool. So I think from an implementation standpoint, we're pretty good. The problem is now that we have this output, but we're not actually returning anything from this function. So we need to add a return here. And what are we going to return? Well, we're going to return the max item. And let's see, did we work? Haha, nice. Okay, so now we can get rid of this commented out code down here. And we can make this even a bit more kind of tersy and ES6y by, instead of using function here, we use const. And then we'll define maxChar as a function that's going to take a string and return a string. And the output of it's going to be this string split. And then we just get rid of this final curly brace, and looks like we're good. Okay, great. And yes, the code is longer and seemingly more complex, but we're actually doing in one pass the whole job as opposed to doing, well, 3 or 4 passes as we were doing in the previous version. So let's go and take this and call it, and we'll call this one the ON pass. And now algorithmically, I'm going to say that this is the best I'm going to do. Maybe you can do better. And of course, if you can, be sure to put that in the comment section down below, link to a GitHub or a gist or a code sandbox or whatever. I'm really excited. Can't wait to see that sort of stuff. I love code golfing like this. But what we can do is we can actually reuse this function a little bit by making it more generic in a TypeScript sense. We already have TypeScript, so can we do better from a TypeScript perspective? And yes, we can. So what we can do is I can take out the splitting functionality out of this. I'll just do, in this case, like string, but we'll say that this is an array of strings. And we're not going to call this maxChar, we'll call this max item. And then we need to reproduce maxChar from basically the same thing. And we're just going to call maxItem and then give it that split that we removed. And now does this work? Yes, it does work. So what we've done is basically reproduce maxChar, but we're actually just calling out maxItem on an array. And so now I can go down here and put in like a new expectation. I can say maxItem. And I can just give it an array of strings, right? I can say A, B, B, and that's going to equal B, right? Because we got two B's and one A. Nice. Okay. Very cool. So that's a decent refactoring, and it makes this a bit more reusable. But can we make it even more reusable? Absolutely. So I can say that we'll take a data type, and we're going to take an array of that data type and return that data type. So basically, we're looking anywhere in this. We're going to have string. We're going to replace that with that data type. String becomes data type, and string down there becomes data type. And this needs to be like undefined because we don't really know the data type. All right, so that's not bad, but we do have an issue here. So the issue is that when it comes to JavaScript objects, you can only use a string, a number, or a symbol as the key. You can't just use any old thing as a key on a JavaScript object. So what we need to do is we need to kind of constrain the data types that maxItem can take so that they only fit those which can be used as keys in that lookup. So I'm going to say that data type must extend either a string or a number in this case. I'll just keep it at that. It was symbol. You can add that if you want. Okay, so let's jump down here. So instead of strings like this, I'm going to use instead some numbers. So 1, 1, 3, 1. And what do we expect from that? Well, that's going to be 3, right? No. Okay, that's going to be 1. Okay, there we go. Okay, cool. So nice. So now we've got a maxItem that actually is generic and can be used on different data types. Well, really just string and number, but I think it's still a nice way to have used TypeScript in this case. So that'll be the last one that we'll use on this project. Copy and paste that down here, and I'll put that into the README as the generic implementation. Max TypeScript. And then I'll save this file out as the final refactoring. And of course, I'll publish this up to GitHub, and you can have a look at it, and you can see if you can do better than me when it comes to this refactoring. Maybe you can make it even smaller, even more efficient. I can't wait to see what you come up with. Of course, be sure to leave all of that down in the comment section down below, and hit that like button if you like this video and you want to see more like it. Hit the subscribe button if you really like the video, and click on that bell and you'll be notified the next time a new Blue Collar Coder comes out.